let's do this deadband thing. First thing, you need to grasp the concept. We have already established, we picked a first cut-in point, and then we got our approximate values for the next two cut-in points. This is the point where when the daylight comes down, first stage turns on, second stage, third stage, whatever. The reason these are approximate values is your controller might not let you put in exact values, right? So these are likely to be shifted up and down a little. Deal with it. The next thing we have to do is establish our deadband. Well, here are things that are set in stone for us. We took a good measurement of the reference illuminance. We know what 1.5 times that is, or 150% of it. And we know what the contribution of our switched lighting is at our reference location. This is very important because we are going to need to ensure that when we insert our deadband and this stage of light switches back off, this switch off level right here needs to fall between 150% of reference and our reference. So anywhere from here to here is acceptable, and we are going to be establishing this point based on the daylight that is entering the space. Now let's remember what we're doing. We start out at reference on our little sawtooth graph because that's the value of A, B, and C all being turned on. Daylight begins to come in because this is no daylight and this is daylight, and we're actually telling the controller points on this line. So you can think of it like this. When the first stage of lighting snaps off, our reference drops, right? And so this line drops, and then this line drops again, right? And that's why we have it here, here, and here in pieces. Now our deadband we're going to express in real life in foot candles, right? In other words, where our turn-off point is above this lighting. In other words, on this daylighting line. This has got to equal, actually exceed, the amount of controlled lighting from this stage that is getting to the sensor, getting to the system sensor, right? Because if you don't have this deadband in here, system's going to cycle on and off and on and off. So our minimum deadband value is based on what we guess or have measured is going to get to the sensor from each of these stages of controlled lights. And because our deadband in this particular controller for this particular system is based on the cut-in values, the deadbands will probably be different for each stage of lighting. Okay, now do recall that we picked this first point and all this stuff was based on it. Now we're going to base our deadband on these points and these measurements. You must have these measurements. You must know how much electric lighting is showing up at your reference location when a stage of lighting switches on. You also need to have some kind of a clue as to how much of this controlled lighting switching on shows up on the system sensor, because that is going to establish your minimum deadband in foot candles. When this one turns on, I measure an extra so much on this thing. When this one turns on, I measure an extra so much on this thing. When this one turns on, I measure an extra so much on this thing. We have to be bigger than that with our deadband. So our deadband can be anywhere between the minimum over the minimum that the sensor sees when a stage of lighting snaps on, and a maximum of where it drops into the zone of 1 to 1.5 times the reference illuminance. That is to make it legal in the state of California. And you can see that your cutout point can be quite high and still drop you into this zone. We know that we're interested in this particular value between the cut out set point and the cut in set point as foot candles. And you need to kind of, maybe it'll help you to picture it if you remove the controlled lighting and realize that this slope section is part of this and this slope section is part of this, because all we're telling the controller is what our presumed interior daylight level is when we want it to switch on and off. It'll do the math to look at what you got here. So when we go to do our combined illumination in the space graph for cut out versus cut in, it's going to be different. It's going to be different because it's going to come up some. In this case, this will drop by C. Whoa. That doesn't look very good. Okay, well, it's going to drop by C. Combined illumination is going to continue to increase. We're going to hit our next cutout. It's going to drop by C. Combined illumination is going to continue to increase. It's going to drop by C. And now it's all daylight. So that's about what that should look like. This, at a minimum, is the contribution of this lighting stage that is hitting the system sensor. The maximum can be way up there, something like that or that. In the next section, we're going to derive two formulas, one based on the amount of daylight that the sensor sees when a particular channel switches on. That's your minimum deadband, and a formula that you can use to determine when you're going to exceed this point, which is your maximum deadband. And if you put it anywhere in between there, you will be Title 24 Part 6 compliant in the state of California. And all you got to do is pick one point, take good measurements, and plug in the numbers, and you're done. Done. Fantastic.